reactivity and metals with medium reactivity. Now, you have seen that metals with medium reactivity will be reduced with the help of carbon. This zinc oxide solid will be reacting with carbon, and carbon can easily reduce this zinc by taking oxygen from zinc, and it will be Zn and CO. So now you can see zinc is along, that means purified. There are other methods also to purify these metals which are moderate reactivity, and it is done by displacement reaction. It is done by displacement reaction. So I'm going to write the high reactive metals. No, wait a minute. Don't write it directly. So the first is basically, besides using coke, that means carbon, reduce metal oxide to metal. You can see this is metal oxide and it is reduced to metal. Beside this method, we can also use displacement reaction. Displacement reaction can also be used. So it's very easy to understand. When more reactive element will react with the oxide of medium reactive metals, when more reactive metals is gonna react with medium reactive metal oxide, it will displace medium reactive metals from its oxide. So how we are gonna reduce it? The highly reactive metals, as you know the examples such as sodium, calcium, aluminum, magnesium, etc. Basically these all etc. are used as reducing agents. They can displace. Basically they are very reactive, so they can displace metal of lower activity. They can displace metal of lower reactivity from their compounds. And this topic is very important because every year one question has been asked from here. I will tell you the example why it is very important. So first of all, if you have MnO2, manganese dioxide, that is reacting with aluminum. As we know that aluminum is very high reactive element metal. So aluminum will take oxygen from manganese. So it will be 2Al2O3 in solid plus, and this manganese will be refined. So there will be only 3 Mn that will be in liquid state. Can anyone tell me, is manganese metal or non-metal? Amna?
Sir, non-metal?
No, it's metal. Manganese is a metal, and we are studying about the concentration of ore. That means we are extracting metal. So basically, and generally all are metals. So basically this reaction is very exothermic. Do you know what is exothermic? You have studied this exothermic reaction or exothermic process in the first chapter. The reaction or the process which evolve heat, that is called exothermic. And this reaction is so exothermic that this metal, that's you can see, this metal is in liquid state, molten state. And this reaction is used to join railway tracks and also machinery parts. Are you getting my point?
Yes,
It
sir.
is it is so much, or it is very high exothermic. And since it is exothermic, it will evolve a lot of heat energy. And due to that heat energy, the metal exists in molten state. And this reaction is used to join railway tracks and machinery parts, metal machinery parts. So I'm going to write. First of all, write up to this. Let me have water. Please write up to this. Martin, if you have any doubt regarding this,
No,
please
sir.
let me know. Let me know when everyone done with this. Please let me know when you are done with this.
Sir, done.
Martin, are you done with this?
Yeah, done, sir.
Okay, thank you. Abdullah, why you don't respond at all? Now see, since this reaction is very high exothermic reaction, and that means it will produce a lot of heat energy. That's why the product, the metal, is produced in molten state. Physical state will be molten state. So I'm going to write this displacement reactions are highly exothermic. The amount of energy released, the amount of energy or heat evolved is so large that the matter are produced in molten molten state. So this is very important point. It can be asked why during displacement of this type of reaction. In this, basically the product is in molten state because of evolution of very high energy. Next point, which is very important. The reaction of iron 3 oxide, that means basically the formula is Fe2O3. I will explain why does it written here in the Roman numeral 3 with aluminium is used to join railway tracks or cracked machine parts. If machine part will be cracked, this reaction is used because it evolves a lot of heat energy which will melt the metal and it will help in join that metal parts. And the reaction is known as, which is very important, this reaction is known as thermite reaction. This reaction is known as thermite reaction. So it has been asked, what is thermite reaction, or write thermite reaction directly in 1 marks. So I'm going to write the reaction for the railway track, joints of railway track. Fe2O3 in solid reacts with aluminum, which is in solid state. Now Fe will be in liquid state, Al2O3. Now basically aluminum is acting as reducing agent. It reduces iron. This will be in solid state and this. So please write it. This reaction is called thermite reaction. And it is very easy to understand. You can see. Let me know when you are done with this.
Sir, completed.
Thank you. Amna, are you done with this?
Yes, sir.
Very. So this is basically for metals with medium reactivity. We have already completed metals with low reactivity and then metals with medium reactivity, which will be reduced by carbon. And the next method is by displacement reaction. The metal with low reactive, medium reactivity, the oxide of metal with low, medium reactivity will be reacting with high reactive metals that will, the reaction will be taking place. That reaction is called displacement reaction. And the most important point here, iron 3 oxide, basically D block element like iron, manganese, chromium, cobalt, nickel. These elements basically are metals, and these metals have variable valence. As you have studied in the in your class that sodium has a valency of 1 only, magnesium will have valency 2 only, chlorine that is 1. Some matter elements, basically some elements shows variable valency, like iron can show +2 and +3. You can say 2 or 3. Manganese can show +2 +3, that means 2 3 4 5 6 7. So basically these are D block elements which shows variable valence, and in order to recognize whether which valency this is used, so it is written that iron in Roman numeral there is 3, that represents, here the iron has an oxidation state, or you can call it the valency is 3. Is that clear? Is that clear to everyone?
Yeah, yes, sir.
Okay, Amna. Okay, thank you, Martin. Now see, extraction or extracting metals of high reactivity, or the metals present or you can say the metals present on top of the reactivity series. Okay, so now these are already, I told you that when I draw the chart, you know that metals with high reactivity will be refined or extract with a method that is called electrolysis. That is called electrolysis. So what is this electrolysis? So basically you can see electrolysis that is related to electric part. So basically I'm going to take a container. This is our container in which we have two electrodes. One is cathode and another electrode is anode. Another electrode is, this is anode. And these two electrodes are connected with a wire. This has negative terminal and this has positive. So this is positively charged electrode, this is negatively charged electrode. That's why this is cathode, this is called cathode, and this is called anode. You already know what is cathode and anode. Negatively charged electrode is called cathode, positively charged electrode is called anode. Now see what happens here. The electron, what happens here, basically we have a solution of salt here, and copper from this electrode will come out and goes and stick to this side. Basically, we are, wait a minute, we are refining copper. You can see, basically we are refining this electrolysis is used for every type of extraction, because if you are going to refine metal, you won't get it in most pure form. In order to get a pure metal, you have to pass through electrolysis. So just suppose you have got copper, you just refined it, and after that you need 100% pure. So you have to pass this copper through this solution, through this process, electrolysis, in order to get 100% or 99% of pure copper. So what will happen here? Copper will be dissolved in this solution and form Cu plus 2. And as you know that this is negatively charged electrode, so Cu plus 2 will be attracted by this electrode and it will go and stick here. So basically, the pure form of copper will be deposited on cathode, and whatever is the basically particles and mud, you can say mud and sand particles will be deposited near this anode, and this is called anode mud. This is called anode mud. So I'm going to write a point about it and then again I will explain. So this is the point. Metals such as copper, zinc, and tin, nickel, etc. Or you can say basically gold also. Gold, that means A, etc. are refined electrolyte. Last step, they are refined electrolytically. Basically, in this process, the impure metal is at anode, or you can say the impure metal is made anode. The impure metal is made the anode. I will explain again, you will get it. And a thin strip of pure metal is made the cathode. I have to write some more points. So please write it, then I will explain. Please draw this and let me know when you are finished. It is very important topic.
Sir,
Yes.
is that this whole last sentence was that this whole?
On passing the current through electrolyte, the pure metal from the anode dissolves into the electrolyte. Are you asking about this?
Yeah, I understood.
Okay. Everyone done with this?
Good answer.
Amna?
Yes, sir, done.
Okay. Now I'm going to write another point, then I will explain. So basically on passing the current through electrolyte, you can see the pure metal from the anode dissolves into the electrolyte. So you can write the next one. An equivalent amount of pure metal from electrolyte is deposited on the cathode, and the soluble impurities, the impurities which are soluble in that electrolyte, go into the solution, and insoluble impurities, whereas the insoluble, wait a minute, I'm writing very bad, whereas the insoluble impurities settle down at the bottom, settle down at the bottom of the anode and are known as anode mud. So please write it again. I will explain what I just wrote. Everyone done with this?
Yeah, done, sir.
Very good. So see what is going on here in electrolytic refinery. We have basically this representation. I'm going to draw it again. We have a container in which we have two electrodes. One is cathode. This is attached with negatively charged of electrode, and this is anode. Anode is positively charged and cathode is negatively charged. Now this anode, oh wait a minute, this anode is made up of that metal that we need to purify. Just suppose it is made up of copper. So copper will be converted into Cu+2 and it will come into this solution. This is an electrolyte. Electrolyte, that means basically it will dissociate into its ions. And this is since negatively charged, so Cu+2 will go and stick into this copper. It will form basically thin strip. And whatever present in this copper, basically the impurities, if the impurities are soluble in this electrolyte, they will be soluble, they will dissolve. And if the impurities are some impurities which are not dissolvable or soluble in this electrolyte, will go and collect under mud, and this is called anode mud. I think I'm clear to everyone. Please let me know if you have any doubts.
Sir, can you repeat?
Yes. So, Martin, this anode is basically the metal we need to purify. Okay. Copper. This is made up of copper. Are you getting my point?
Yes, sir.
Now see, when you dip this into this solution and start passing electric current, what will happen? This copper will be oxidized. That means basically it will fall down, dissociate and fall down into this solution. This is initially copper, and when the electricity will go on, it will be converted into Cu+2. It will lose two of its electron, and it will come into the solution Cu+2. It is like Cu+2 continuously falling from here, Cu+2. Now you can see this is negatively charged electrode. So you know that opposite charge attract each other. So Cu+2 will go and stick into this cathode, this electrode. Are you getting my point?
Yes, sir.
Now, whatever was attached with this copper that we are going to purify, that is called basically gangue or impurities, you can call it. If the impurities are soluble in this solution, they will dissolve. And if they are not soluble in this solution, they will collect under mud. That is called anode mud. Now the purified or the pure metal, where it goes and stick to the cathode. It will make a thin strip at cathode. So you will get your pure metal from there. Okay.
Okay, sir.
Please write it. Is everyone done with this? Please let me know when everyone done with this. This chapter is almost complete. So we are gonna start a new chapter, carbon and its compound, in the next class. Okay, Martin.
Yeah,
Are you done with this? Can I change the slide?
you can change.
Hamna, Abdullah.
Yes, sir.
Okay, thank you. So I'm going to. Can you see the new screen? Martin, can you see a new screen?
Yeah, I can see exercises.
Okay, please do question number 1, 2, and 3, and 4 on. These 4 questions you are going to do. This is from NCERT. What is the answer of this first? Amna and Martin. Which of the following pairs will give displacement reaction? This displacement reaction will depend on reactivity series. So basically, we know that from here you can understand. NaCl copper metal. Copper cannot displace Na because it is very reactive. Aluminium also cannot displace magnesium because magnesium is more reactive. Silver cannot displace iron, but copper can displace Ag and Ag from its solution. So answer will be D. Martin,
Yes, sir.
very good. Now just leave this question. You can do this. Basically, it is also from, if you have studied it in the first chapter, corrosion. Which of the following method is suitable for preventing an iron frying pan from rusting? What do you think? By applying grease,
Applying paint.
applying paint? No, you cannot. It will not that much
Coating of
effective.
zinc.
Yes, coating of zinc will be quite good method, because if oxygen will come, it will react with zinc and it will form zinc oxide. But zinc won't allow to go oxygen to iron. Okay. What is the answer for the third? An element react with oxygen to give a compound with a high melting point. This is a compound is also soluble in water. The element is likely to be calcium, carbon, silicon, iron. What do you think? See, it's very easy to understand. An element react with oxygen to give a compound with high melting point. So which type of a compound is high melting point? Ionic compound. So oxygen is non-metal. Ionic compound forms between metal and non-metal. If oxygen is non-metal, the another compound should be metal. So either it can be calcium and iron. Now it is also soluble in water. So basically calcium oxide is soluble in water. That's why the answer will be A. Okay. Food cans are coated with tin and not with zinc because what do you think? Zinc is costlier than tin? No. Zinc has higher melting point than tin? No. Zinc is more reactive than tin. That's why tin is used instead of zinc. Is that clear to everyone? Martin, Amna?
Yeah, yes.
So in the next class, you are going to do homework and NCRT exercise question. All the NCRT exercise question of metals and non-metals. I'll see you on next Monday. So I'll check it out. Okay.
Okay, sir.
Wait, what's the homework?
Yes, Martin, what you just said.